So here we have a bunch of information given to us in the table. So a company surveys its employees to which types of snacks should be sold in the vending machines, and we have this data here. And obviously, you know, the coffee crisps are the most popular because they're definitely the best chocolate bars. So here we have, we can figure out what kind of graphs we can represent this data. Now we could try to use a line graph. Well, does the line graph really make sense here? Are we going to compare the values of the names to the number of people who, no, that doesn't seem to make sense. So really a bar graph or a histogram is going to make the most sense for this. So we can draw a bar graph for this, and we need to make sure we have some scale here. So I'm going to maybe make my scale like this, so 10, 20. Okay, and we can put in our bars for Kit Kat. Okay, so we have our Kit Kat here. And I'm going to maybe change colors here, make it look nice. Oh, maybe I'll even shade that in. There we go, Kit Kats. Coffee Crisp, we'll use, do we have like a gold color for Coffee Crisp? We'll use maybe like there. Okay, Coffee Crisp. We have 22. Okay. Actually, I'm going to do yellow because the wrappers are yellow. So I'm just going to do yellow here for Coffee Crisp. Okay, there we go. There's my Coffee Crisps, my Snickers. They come in a brown package, I think, if I'm not mistaken. So where's my brown? We'll use brown here. Okay, so my Snickers was 12. Okay, so there's my Snickers bars. Okay, and Mars bars, we'll do that in black. I'm pretty sure that they kind of black packaging. So Mars bars, you know, they're not that great. Mars bars. Okay, and then Twix. Twix are pretty good. I love Twix. So we have Twix. Let's do Twix in, I think they're kind of gold, but maybe we can get a different, we'll just do it in orange here. Twix bars, we're going to have 12 of those in there. Okay, so it's going to be a little bit taller than, it's going to be same as Snickers. Okay, so there we go. There's our Twix bars here. And so here's our graph represented in bar graphs. So obviously the type of graphs which represent this data is best is bar graph. Okay, and we can get a good sense of what kind of proportions of coffee of chocolate bars we should have in this vending machine. Okay, so let's make a pie chart. So what we want to do is we want to take these percentages and put them in the pie chart. Now, to be able to get a good sense of what we're dealing with, we should kind of have a sense of the angle. And I want you guys to draw this with convert the percentages to angles, number one. And then, you know, the angles don't have to be precise, but you should be relatively close. Now, one that's really easy to do is 25%. So I'm going to start with that. And I know that's 90 degrees. Okay, and final math grade of B is going to be 25%. I know that's going to be a quarter. So this is my B grade. Okay, so there's my B grade, and that's a good place to start. That's 90 degrees. So I'm going to go for A's here. Okay, in this class, there's only 10% A's. That's going to be 36 degrees. Okay, so 36 degrees is going to be something about here. Okay, now I'm not going to measure it exactly, but I know that 45 is half of the 90. Okay, so that's a little bit less than half. Okay, so we have 35%. Okay, so 35% of 360 degrees. Okay, so 35% of 360 degrees, we're looking at 126 degrees. So let's see here. So let's go right about 126 degrees is probably right about, I would say, right about here. Okay. And again, I want you to be a little bit more precise with that and actually measure the angle. So this is going to be C, grade of C. lots of C's in this class, 126 degrees. Okay, and we have D is 72 degrees. Okay, so that's going to be 72 degrees. Okay, 20% represents 72 degrees, so we're going to have a little bit less than 90, so something like that. Okay, and so this is going to be my D. And the F and incomplete are going to represent the last 5%, last 5 and 5. Let's choose a color here. Let's go with blue. Okay, so we have our F. Okay, we don't want to be failing our courses here, but there we go. And then we have our I's in there as well. Now the I's in black. Okay, so you need to make a graph that has these relative proportions. Again, make sure you have your able to convert these into degrees, so and be able to relate the percentages with degrees and be able to see how they look like in a circle. Okay. So this next one here, we're looking at the height of BMX jump, a bike that can jump, and the mass of the bike. So here we have the mass of the bike. That's gonna be our, and this is now becomes a question you need to make sure you can answer. Which is a dependent variable? Which should go on the y, which should go on the x? Okay, so in this case here, the height is dependent on the mass. So we really should have the mass along the x-axis and the height along the y-axis. Okay, so I'm going to start my graph maybe at like 8 kilograms here, and then I'm going to go like to maybe, it goes up to 12, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So about, let's divide them into increments of 5. Okay, so we're going to do 9 here, 10, 11. Okay, so that we have our increments and mass in kilograms here. Okay, and then we're going to do our height along the y-axis. Okay, so our y-axis height, we're going to put our scale. So we might want to exaggerate the scale a little bit. So let's start at 10 and go up to 30. So 4, 5, 6, 7, 8, 9, 10. So let's say that's 30 here. Okay, so halfway is going to be 20. Okay, so that's going to be 20 kilograms here, or sorry, 20 centimeters here. So this is a height in centimeters. Okay, and that's the mass in kilograms. So then at 9 kilograms, we're going to jump 29 centimeters, right about there. At 9.5, so halfway, we're going to have 28. So it's going to be right about there. Okay, at 10, we're going to be at 26 here. 10.5 is going to be 24.5, somewhere around here. And 11 is going to be 23.5, so 23 is right about there, so 23.5, maybe somewhere around there. Okay, 11.5, we're going to be 21.5, somewhere around there, and 12, we're going to be at, sorry, this is 12 here, 12 kilograms. So we can see that there is a decreasing trend. Okay, so it's a negative trend. Okay, and we can kind of say that, well, is there a pattern where it's a decreasing trend? Decreasing trend. And then we can say that at the heavier the bike, the less it jumps. Okay, so if the mass was 15 kilograms, so if we were to extrapolate, we could actually use the slope here to predict the jump. So if I draw a little bit straighter line, okay, and I can estimate the slope. Here it looks like it's going down. Well, it looks like it's going down about 10 centimeters for every, looks like approximately, let's say 3 kilograms. So if I go up another 3 kilograms from 12 centimeters, or sorry, 12 kilograms, so we go to 15 kilograms, so we know that it's going to be minus 10 centimeters for every 3 kilograms of mass. So if we get to 12 kilograms, we're probably going to be jumping, what would the height be? Well, the height is at 20, so let's say at 15 kilograms, we would estimate maybe about 10 centimeters of height. Okay? So these are the different types of graphs we can do. I mean, there's many, many more, because we can display data in lots and lots of different ways now, especially with all the technology that we have. So one way is that we can do is, some of you may be seen this, is something called Wordle, where we can take a look at, as words get input into a document, it will take the most popular words and make them bigger. Okay, so population is big because it's the most popular in this conversation. School. Okay, the really, really little words are less popular. It gives you an idea of the relative popularity of these different words, and gives us an idea of maybe what this might be talking about. So these videos, visualizing Twitter data, and this other one, visualize data, there's some links here. I put the links in the calendar as well. But it's a good idea I want you to take a look at these and just get a sense of these different ways now we can show data, and to be able to display data, and to be able to infer much more information now because of these different ways we can display data.